Hi, this is a lab for gas chromatography mass spectrum, also called determination of bisphenol A in canned food. So for this lab, the first part is preparation of the solution. And first, for prepare 101 mixture of water and ACM by mixing equal amount of each to create enough solvent to perform all of the dilution mentioned in the section, plus a little electrode just in case. This will be the initial solvent for dissolving the BPA and also for the initial extraction of BPA from the canned food sample. Dissolve 100 milligram of BPA in a little less than 100 ml of the water solution. Stir at room temperature in the film hood. Make sure dilute all the volume with the solvent in 100 ml volumetric flux once the BPA has all dissolved. And use the 10 ml of the solution with the first step called derivatization below. For the quantification of BPA in the canned food sample, you can measure all of the known amount of the canned food contained with 50 ml of your water solvent in a beaker large enough to hold everything. If using juice from canned food, then you use 10 ml of the liquid. So extraction step, obtain a HEPARSEP C18 solid phase extraction cartridge and condition it by passing through one full tube of methanol, followed by one full tube of DI water. And for the Scalc solution, remove 10 ml of the solution and use the volume only. The BPA will be concentrated onto stationary phase in this part. And in the cartridge during the step, once all solution has passed through, fill the tube with 5 ml of the ACN water, solvent, and pull that through. We will dry the filter by pulling air through for about 1 minute. The solvent containing any hydroxide group must be removed before the BPA can be derivatized. Derivatization step, run up to the 5 ml of the solution and until completely dry, and it is important that all solvent is removed. To dry the BPA in the round bottom flask, add 50 micromole acyl acetate, swirl the solution for about 1 minute to make sure the BPA is dissolved. Next, add 50 micromole BSTFA and 1% TCMS to the solution and heat to just below 70 degrees Celsius in a warm water bath in the film hood for 15 to 20 minutes. And occasionally stirring gently by swirling the flask from the solution, use finding the ideal temperature and parameters. Dilute to a total volume of 100 ml in the acyl acetate. Calculate the final concentration of BPA in this solution. This is the concentration of the standard solution we will be using to find the GCMS parameters. And for the calibration and unknown food sample, dilute the volar volume of 10 ml and 5 ml respectively with acyl acetate. Calculate the final concentration of BPA in the calibration standard, assuming that all the BPA came out from the SPE cartridge and into methanol phase. Part 3, identification of the ideal instrument parameters. So first, the GCMS study performed using thermal scientific trace 130 gas chromatographer and the thermal scientific TSQ dual mass spectrometer. Keep that at 70 degrees Celsius for 0 to 2 minutes. Linear ramp from 100 degrees C to 2500 degrees Celsius for 2 to 8 minutes and hold for 250 degrees Celsius for 2 minutes, and were the step used to determine BPA. And here we use a different flow rate from 0.8 to 1.5 ml per minute to find the mobile phase. So for part 4, the GCMS analysis for the sample. So for the standard addition, and you will make 4 standard addition to your unknown sample and get 5 auto sample well in the 1 ml of your unknown BPA solution. To each, you use a micropipette to add 100 microliter, 200, 300, and 400 microliter of BPA standard. In the mass spectrometer, scan range was set to 70 to 40 /C, and the data was obtained after 4 minutes. Peak, head, and region were calculated in 2 sets of MD ranges using the equipment program for each chromatograph. Thank you.